Commercial electric vehicle charging points, that's what we're doing today. We're going to show you the whole process of installing this Easee charge point at this workplace. Make sure you like and subscribe. Let's get into it.
Tug of war.
There we go. So just to explain a bit of the background here, you see before us a finished base ready for our pedestal. That's because we have a groundworks team that we work with who've come here a few days ago, prepped everything for us. So this is what we call an EV block. It's a specially designed base for electric vehicle charging point pedestals. It just enables us to get a duct from the building to here, bring our cables straight into the base of the charging point. The EV block is adaptable for various different charging points, different size pedestals and stuff like that. From here to the building, there's two ducts, one for now and one for later, because we future-proofed this install. One of the ways that we future-proofed this is rather than having to get groundworks done again later if they want another charging point over there, we've got the ducts put in already because it's easy enough to do it now, not so easy to do it later. We've got two here, so we can use this one. I think it's the one that's moving furthest back.
It's this one here.
Oh, okay, yeah. So we've got a 6mm 5-core steel or armoured cable going in. That will give us 3-phase power to this charging point, which means that it will open up the possibility of 22 kilowatt charging. Most vehicles can only charge at 11 kilowatts maximum AC anyway, but some can charge at 22, so they'll have the possibility there. In that side, we've got a whole new distribution board to fit, but what we're going to do first is get all the outside stuff done while it's nice and sunny, and then we'll work our way to the inside and show you that. This is always the head scratcher moment for me, is figuring out whether we should put it in that way and then pull it into the duct here, or whether we should pull it in that way and then into the building. Yeah, let's do it that way, I think. Slide it through this way and leave the rest here, then we can pull the rest through there afterwards.
Feels like someone's just used their clothesline as a draw wire.
It's pretty standard that. I think usually they sort of say you should use that to pull through a rope and then tie the cable onto the rope.
Right.
But as it's such a short run, I think we should be all right just tying it onto that. So we'll tuck this spare duct out the way for future use. This one will protect this cable, and we can always tuck a little bit of slack under here. So that's the nice thing about the EV block. You've almost got like a maintenance pit that you can use to hide a bit of the slack and give yourself a little bit of wiggle room. So now what we need to do is mount the base of the pedestal onto here, and then we can bring the cable up inside the pedestal, mount the charging point. So this is the base of our pedestal, which will fit nicely on there. We've got 4 holes to fix it down to, so we need to make sure it's nice and square, and then we need to drill 4 holes here, put bolts and nuts. This bolts onto there, so we've actually got some screws to go from here that screw down into these. These are threaded, and that means that you can kind of choose which angle you want it to go at, but we'll go pretty much square. Then there's a nice access hatch, so you can sort of pull the cable up. There's a connection plate that we can use in here as well. This is an option where you can basically loop in and out of the charging point. You could run it on a 80 amp circuit, for example, and loop in and out of here between various pedestals, because with the Easee Chargers you can have up to, I think, 100 charging points off one circuit, and then they'll do load balancing between them all. In the installation that we're doing here, we're running just one cable out here, but we've got the potential to run a couple more in the future. So we will run the cable straight to the charging point, and then if we wanted to add a second cable later for a second charging point, we'll run it straight from the distribution board, because we've got enough capacity in our distribution board that we're fitting to be able to do that. But if you do want to run a whole plethora of charging points off one circuit, this device enables you to do that, and you basically just connect your incoming cable there, your outgoing cable there, and then you've got your flex up to your charging point and then another flex up to the second charging point, so that you can run 1 or 2 charging points off of this and then run to another pedestal, and so on and so on. You can just loop in and out sort of indefinitely almost. So these are M10s, and we've got an 11mm drill, so that's fine actually.
Did you want a 10mm or did you want to just stick
I
with
think 11 will be fine. Gives us a little bit of wiggle room.
Yeah.
But we will need one that we can just use as a pilot bit to start with, so maybe just get a smaller one to start with. These penny washers are absolutely massive. So I don't know why this pedestal, but it comes with this, you know, these huge holes. So obviously if we use a bolt on that, it's just not gonna hold it down. Fortunately, I was able to find these giant penny washers. So those will go on there. And then on the back, we'll put another penny washer and a nut like that. So with this, what we're going to do, we're going to position it so that the charging points will be on the sides. So this is the bay that we're provisioning at the moment. So we're going to put a charging point on this side. This side we're going to blank off for the moment, but later we could actually put one on there. So we'll slide our armoured cable up into there. Okay, push, that's it, perfect. Great. Okay, got enough length, so that's good. We're going to have to figure out how that is going to come into the charging point, whether we gland it or not. I don't think we should be glanding it because we've got a pen fault protection device at that end, and I don't think there's an actual way to gland into this particular charging point anyway. So this is the Easee charging robot, and it's probably our go-to charging point for commercial applications because of how flexible it is in terms of load management, and also the back office payment system ability of this is really, really good. So it's just a socketed, it looks really smart. Got this little tool here at the back. So this is a little trick, Ruben, that you're going to need to know. I made this mistake before. I was like, how on earth do you get it open? You use this tool that they provide. You do that. And then it's a bit fiddly. But, or you can just do it that way. It's a bit stupid, that tool. Not quite sure why, but there we go. So this is just a front cover, and you can have black, blue, white, red, grey on those, so that's nice, gives you flexible options. And this is a robot, and that just unclicks like that. So this has got pins to clip it into the base, and then in here we've got our installation kit and our terminals that we're going to use to connect our cable in. So that is our cable entry point. We can clamp it down there, but you're never going to get an armoured gland in there, I don't think. So this is the base that the charging point goes onto, so that will slide over. We've got the screws, 2 at the top and 1 at the bottom, which will fix this to our pedestal, and then 4 holes where the charger will mount to this base. We've had a slight change of thought, so we were going to take the armoured cable straight into the charging point, but to be honest, it's a bit tight to get an armoured in there this size. It's a 5-core 6mm or 10mm, whatever. It's a bit tight to gland it in here and everything. So what we're going to do is we're going to use that connection plate, take it into there, and then run a flex from there up to the charging point. It'll be much easier to do everything like that. And then a second charging point, when we add it on, we can always just add it on this existing circuit, which will mean that they've got still 11 kilowatts, you know, from each charging point available. And it's going to be super easy to just add a second charging point on the other side. So this is our distribution board. As you can see, we've got plenty of spare three-phase ways here. We're going to install a new 63 amp circuit in here, three-phase. This board is fed off 100 amp main MCCB in this board below me, in this panel board. Then what we're going to do is run from here through this trunking, hence why we've got this 10mm 5-core flex, just to make our life a little bit easier. We're going to run it down, drop it in, and put this MATI device here. This is basically like a distribution board, but with pen fault protection built into it, because those chargers do not have pen fault protection built in, so we need to put this additional safety device, which is called a MATI. It's an O-pen device. We've done lots of videos about those, so head to the link in the description if you want to learn a bit more about that. But basically it's got 3 outgoing ways, so we future-proofed ourselves by putting this in rather than just a one-way board, because later if they want to add more charging points, they can run them off of this. Now the great thing about these Merlin Duran Multi-9 boards is that they're really safe, because these teeth on the bus bar only come live when you switch this switch on, like that. This is really safe, and it means we can work safely in the board without having to isolate the whole thing. Obviously still need to be careful, but it's a lot safer than if there were loads of live bus bar teeth here. So we'll probably put a new 3-phase breaker in here and then run our HO7 flex down through this hole, through the trunking, and then drop into the top of our board here with a coupler. We're going to have to move this to the side so that we've got enough space to put our new board in here. So we'll get Ruben to do that, and then we'll get all that mounted. But the reason I've taken the cover off here was just to make sure that we've got enough spare flex that we can basically connect into our breaker, run into our board. So that's enough to go into our board, into our main switch. We've still got a couple of meters spare, so we can use the spare meter over in our charging point. Today's video sponsor is Tradify. Tradify is a job management platform for tradespeople like us. We use it all the time to run our jobs. So my phone has a Tradify app. I can see the jobs that I'm doing today, the jobs that I'm doing the rest of the week. I can send quotes to customers, I can send invoices to customers, all in the Tradify app. Whether you're a one-man band or a company of 200 people or more, Tradify can help you to get on top of your paperwork and organise your scheduling. So head to the link in the description where you can get 50% off using our special code. Thanks. Cheers, mate. That is solar panels for a job that we're doing, and they were supposed to arrive yesterday. Apparently the lorry broke down. How convenient. So today they said, well, it'll be the first drop of the day today. Still no news. So I am slightly worried, because we're supposed to be fitting the panels tomorrow. Why do they put powder in cables, Ruben? Any idea?
I have no idea.
So that if you need a bit of extra talcum powder, you can just... No, I think it's just to make it easier to strip. It's almost like lubricant, so you can just pull it off. But let us know in the comments if you know any differently. So the great thing about these Easee Chargers is the terminals can take up to 10mm squared conductors, which is fantastic. So this flex, although it is a little bit over the top, we could probably get away with 6 or 4mm in this situation. It sort of future-proofs it if they ever want to upgrade it to a 63 amp breaker for this particular charging point, then could be doable. Are you looking for my ferrule crimper?
Yeah.
I've got a pack out for it.
Oh, nice.
Yeah. Oh, so that's your job for today, Ruben. Sort those out.
Not the first time I did that, is it?
So this is a really nice tool. We did a Tools for Sparks video on it, so if you want to see a more in-depth review, check it out. Nipex 1252-195s, made for panel wire, so if you do panel building, it's perfect. But for these kind of fine stranded cables, it's absolutely brilliant. I like this because you can take this out, get all your connections nice, and then put it in. So it makes it quite easy, which is the name of the charging point manufacturer, so I guess it should be really easy. call this a power rail, and it's basically like a bus bar that connects these four, runs all the way through, and then you can loop in and out. It's a brilliant idea actually. It's a little bit like they do in lampposts. I think it's great, definitely a fan. So this is to actually earth the column. So what we've got to do is pop that in like that before we fix this back, and then that will make sure that this column is properly earthed. So it's important to note that you need to do that before you fix this back. Oh no. Drop the nut. Knew that was going to happen. Did they give you a spare?
It's got in the hole.
Oh, for goodness sake.
Have you not got one in the bag?
Why do they design these kind of things so badly? That is ridiculous.
Surely you've got one somewhere. Take this whole thing
in the fixings tray here, have we got I think it's just an M6 nut. We've just made a big boo-boo and dropped the tiny little nut from this column earthing base thingy down inside the column, and they only give you one. So now we've got to take this whole thing off and see if it's down on the floor. Hopefully it's fallen all the way through to the bottom of this EV block, but it's rather frustrating when you drop nuts. And a little tip I would say is, if you are gonna be fiddling around with it like that, just maybe put something underneath to catch the nut just in case it falls off.
What colour is it? Oh, that's it.
Oh, you got it. Oh, yes. Amazing. Right. It is really fiddly. So pedestal's all done. Cable's connected at that side. Now what we want to do is get the cable in to here, ready to connect into our new distribution board. So we're going to drill from the inside out first with a little pilot hole, and then we'll probably drill from the outside in with the final cable. And it's always good, if you're drilling from outside in, it's always good to drill up at an angle slightly so that moisture doesn't drip down the cable into the building. That is good for us anyway, because the cable's coming up from below. We want it to slope smoothly into the building. So we'll try and drill down at a fairly steep angle to get a nice smooth sweep with our cable. No, that is not, that is, oh no,
Damn it, Max.
I think the universe is telling us something. We should just stop trying to be something that we're not. We just face the facts. We're not organised, we're not neat and tidy. We're just a bunch of oafs with a mixed up box of ferrules.
Don't even have a box of ferrules anymore.
So this is Apprentice training time. New little segment jingle, Apprentice training time. Right now, we're going to test Ruben's knowledge of safe isolation procedure and how to identify and isolate a circuit. So Ruben, your mission is basically to turn this socket off, isolate the circuit safely so that it's safe for us to work on, because we're going to move this socket over to here, out of the way for our new distribution board. So the board cover is here.
Oh, yeah,
so it might be fed from this board.
I mean, but this isn't plant room.
Yeah, that's it. Yeah, this is plant. This is definitely a plant room. Yeah.
Fair enough.
Yep, so where the boiler is, where the DBs are and stuff, this is about as plant room as you get. So it is, it looks like that one, and it just says 13 amp socket. It doesn't say 13 amp sockets or anything like that. So if you look at the breaker that is related to that.
2, 3, 4, 5, 6, 7, 8, 9. Bottom one here.
That one.
32
Yeah. So you've got one cable going out of it, and in the socket, how many cables have you got?
Just the one.
So it's quite likely that it is just that one socket.
I mean, to test that it is that socket before knocking it off, I could.
Yeah. Do continuity.
Yeah.
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 Time to isolate it safely now that you've identified the circuit. Yeah. Now what should you do?
So I'd make sure this is working.
Good. Yeah.
By using that.
Well, you can do it on a known
good.
supply. So
Right.
if Now you could do it on the main switch. What is the disadvantage of doing it on the main switch?
I'm not sure.
Well, there's no circuit protection other than a massive 100 amp MCCB. So if you did slip and have a little mistake, you got 100 amps. It's going to go big. It's going to go bang, big style. So why not test it on the back of a circuit breaker? You know, if you had a 6 amp circuit breaker, you could test it on, then that would be fine. There's a 10 amp there. Right. So you could do it on that. Just test between there and earth, for example, just to make sure that you do have your test is working.
Yeah.
230 volts. Perfect. Because then if anything happened, the 10 amp circuit breaker would blow, and you've only got 10 amps of volt current going. So
then nothing there. It's still working.
Yeah. So you can do it that way, but how do you actually know that that socket is dead? Because it's that socket you're removing, it's not the circuit breaker. Great. And then
it's still working.
Great, okay. So now the final stage is to use one of these to lock it off. Merlin-Duran, or Merlin-Duran, because it's a French brand. Do you know what the modern equivalent is?
No idea.
Because they don't make these anymore. Any random guesses?
I don't know. I would say Hager.
Have a look in that bag, and you will find the modern equivalent.
No, Schneider. There we go.
There you go. Schneider, or Schneider, as somebody once told me, which
Schneider
doesn't quite sound.
Doesn't have the same ring to it.
I think Schneider is good for me. So what we're going to do for our DB for our EV is we're going to probably stick that in there somewhere, because Schneider basically bought Merlin-Duran, or they changed their name from Merlin-Duran to Schneider. It's fine to use a Schneider breaker in this board. So what we have to do is just tighten those up, flick those switches across, and then that would be breaker on, and then we can run our H07 down through here into our new board. So why don't you remove that socket and then relocate it. I'll start connecting this in. So we're just going to put 2 bush and couplers in here now to allow us to get our main cable in here into our main switch. This one is not really necessary, but I'm just putting it in there to sort of balance things out, and also allows a future access hole if needed to bring any future cables in. So just to update you, Ruben's lost his safety glasses. I'm sure he will find them somewhere, but these safe style glasses, by the way, if you like them, you can get a discount in the description. They are really, really nice. They're also quite expensive, so it's not good to lose them. So our cameraman had never seen bad lip reading. I cannot believe it. So we've just been enlightening him on the wonders of bad lip reading. If you haven't seen it before, absolutely hilarious. Bad lip reading Star Wars, just search on YouTube, it is hilarious. A bit of light entertainment while we're doing a board is always fun. So while Ruben's busy in there glanding the cable at the other end, I'm going to look at fixing these bump stops now. I want to get them in the right position so that basically nobody can reverse into the pedestal and snap it off, because that would be a disaster. So we put these in so that it stops their wheels from going any further. I'm going to use my van as a test case, reverse it back and just see where we're at, and then hopefully that'll be the right position for most vehicles. So I think that is pretty much perfect. What we want is, yeah, so the bumper is about at the back of the space anyway, so it's not like they're going to be losing space. Some cars obviously stick out a little bit further, but you can see there we've got another 30 or 40 centimetres of room to play with, so I'm happy with that. So I'll level both of those up and then get them fixed down. So the space is 8 foot basically, 245. I think that'll be fine actually, because it's got to look right. Yeah, that looks right. Tiny little tap this way. That's it. So I've got my Marksman deep hole marker, and I can use that to put a mark of ink where the holes need to go. There we are. With a 16mm drill bit, we should be right on the money. So we're going to use these anchor bolts to go into the hole. When we tighten this up, then it will actually expand the anchor bolt and it will grip itself into the hole like that. What you want to do is get the thread flush with the bottom there, put it down into the hole, and you want to tap it down until it's flush basically. Then give it a bit of a hit like that, and then what you want to do is tighten it up all the way so it's nice and flush to the floor. Now what we're going to do is tighten it with this, and that will make the claws expand and basically get nicely bedded in there. That is not going anywhere. So once we've tightened it up so solid that you can barely wrench it anymore, then we go and untighten it, remove the actual bolt, and then we can put the bolt through our bump stop and secure it down again, knowing that these anchors are solidly in place. Ruben has just done an absolute cracking job on this, let me show you. So he's terminated this armoured in here. Look how neatly he's done it to swoop those cables in, and he's tucked them behind the bus bar as well so you can't see them. Done a lovely neat loop there, and a neat loop up into the earth. Proper artisan in the making. So Ruben just asked for R1 and R2, do you have to do it on each face? So what would you think? Why do we do R1 and R2?
I mean, I guess you're just testing the resistance, like, of the cable, but if it's all the same distance.
What are we testing the continuity of when we're doing R1 and R2 really? What are we trying to find out?
To see if there's a path back to Earth.
It's the Earth continuity, yeah.
Right.
So R2 is Earth, the CPC.
Right.
So you can do either a long wander lead, which is an R2 test to make sure you've got continuity, or you do R1 and R2, where you basically use the live as the way to get to the point and back. So you just the point of that test is to make sure that you've got Earth continuity.
Right. So the fact that the line doesn't really...
It doesn't matter which phase you use. I mean, if you wanted to, you can even do N and R2, I suppose. Yeah. But the reason we do R1 and R2 is because we're also checking the polarity.
Right, okay.
So you're making sure in a single phase circuit that the live and neutral are not the wrong way around.
Right, okay.
But in 3-phase we check our polarity by doing a phase rotation test.
Right, okay.
So it's 2 separate tests. But that was a really good question. Yeah. It's logical.
So first, while it's dead, I'll do R1, R2. So I'll link it out at the board. I think it was, oh yeah, it's locked off. So between there and Earth, and then socket, like attachment onto there. And then once it's livened up, I'll do ZS.
Yep. Something else you should do?
Installation resistance.
Yeah. Now often, if it's a socket circuit with loads of sockets and stuff plugged in, you won't really be able to do that because there'll be false readings. But as if only one socket, you can feel free to whack 500 volts through it, knowing that there's not going to be issues. So it's a good practice circuit.
Yep. The screw that's not loose.
How did you manage to do that?
Hmm?
You just done it?
Wow.
Oh, great, well done, perfect.
Yeah.
I've never managed to use that little clip to clip onto the MCB like that before. You've been working with John.
Yeah.
Well done.
It doesn't feel... Well, and then that just... Felt about right. It's made in Norway, just like Corey.
So we're all powered on, the testing's done, and now we're doing the commissioning, and it's all very easy using the Easee app. So we've got a scanner built in. We click activate scanner, and then we're going to hold our phone near the white sticker on the back plate, and with RFID technology, NFC technology, it detects it straight away. Then we name the position of the back plate, so we'll put Easee 1, click next. We don't add another back plate, so we're done. Are you sure you configured all the back plates? Yes. Circuit complete, I'm done. And that's it. So that one is commissioned. Now, all we've got to do is pop our charging robot on, like so. And that is livened up. And then we pop our cover on. Easy as that. So now we're going to run through our functional tests. We plug our simulator in. We put it on B, that's like ready to charge. C should start to activate the charging point. If we do a tag, RFID tag, what does that do? Not a lot. Oh yeah, there we go, we've got power. So it's all lit up there. So that is activated now. I put it on C again, yeah, it activates straight away because you can see the lights have lit up. Now I need to figure out how to program these so that not everyone can do it, and it gives me an easy thing. It says on the back, register here, Easee Cloud, and it gives me the serial number. So I'm going to register this now. So we can change the access control to access for only approved users. Save. So that is it, the end of another fantastic electric vehicle charging point installation. Thank you for joining us and watching. Make sure you like and subscribe if you haven't done so already. And why not grab another cup of tea and watch another video, because we've got tons. There'll probably be more popping up after this. But either way, thank you for watching and have a great day.